And the answer to the warm-up is going to look like this. How'd we do? So just a couple quick reminders for you. Brackets go with anytime you're equal to something. My inequalities here, whenever I have what I call, I just think of it like as a sandwich. You have two dots and then you have a bunch of stuff in the middle. Whenever you have that, your inequalities are always like that. They're always facing in that direction. So you hopefully do not get that one wrong. That's an easy one to get right. And then you got to make sure you have a parenthesis on the negative infinity. So that's our quick little warm-up. And now straight into the lesson. I don't want to do that much. Do that. So we're going to graph this. And we kind of did this yesterday. We had some nice x-intercepts, and then we graphed it, or we had a graph in front of us, and then we compared it to 0, and we saw where it was above 0 or below 0. And today, you get a function, and you have to factor it. You have to make it as the graph. So, how do I factor this? Just start with that. How do I factor that? Thoughts? It's kind of a mix of chapter 5 and a mix of chapter 4 put together. You've done this before, so I'm not going to give you the factoring. You got to think of something. What should we try? Does it have a greatest common factor? No. So what do you think we should do then? How should we factor that? I actually like the idea of taking the square root. So if you can take the square root, that means you can factor it very easily. The only issue with that is this middle piece of negative 17. So that one's going to kind of stop that one from happening. But that's a really good idea. That's actually the next thing I would check for is, can I take the square root of both of them? And in this case, there's 3, so that doesn't work out. But that's a really good thought. So folks, you got 3 terms. So you're going to start factoring it into something like this. Hey, speak up. What do you got there? Ah, you got it. So we're going to steal this. We're going to plagiarize Cade's work here. And we got an x squared right there and an x squared right there. And then he put minus 1 and minus 16. So let's think about that. Negative 1 times negative 16, does that multiply to 16? Yes, it does. Then I go negative 1 minus 16, that adds up to negative 17, so that checks out. So that's good. Now, this is still going to be greater than 0. Have I factored it completely? No, because now I can actually take the square root. I can actually do that for both of them. And so the difference of perfect squares is screaming at you, and so this factors to an x plus 1, x minus 1, that's this first part, and then this one factors to x plus 4 and x minus 4. So that means we have 4 zeros that we can see quite easily. So I'm going to have a 0 of negative 1 comma 0, 1 comma 0, negative 4 comma 0, and 4 comma 0. And so we'll plot all those points. Does a degree 4, does it go together or does it go in different directions for the end behavior? brackets together. So it's either both going up or it's both going down. Is it positive or negative? It's positive, so that means it's going up. So both of them are going up. Do I have a bounce or a cut? No. I don't have any bounces, so I only have cuts. So I'm going to come through, I cut, 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 go all the way up and through. Question? Ooh, that's a good question. So it is not going to be a dotted line. And I'll get more into that actually at the end of the lesson. But when we are comparing functions to a number, then it is just the graph of this. So it's like y equals this function, and we graph it. And then we have y equals 0. And so I'll graph that as well. And so I'm comparing these two things. If I had y there instead of a number, 100% dashed. Okay? And so that's a distinction that I really hone in at the end of this, and we look at the differences. But for this one, that's it. That's our graph. Okay? So this is our graph. Now this is saying this function is what compared to 0? Is it less than or greater than? Greater than. So that means it's above. So we're looking right here. So I'm looking at this, and I'm looking at this. So it's still kind of new for you, so I'm going to kind of be the driving force here. But the really important thing are actually these x-intercepts. Those points are going to show up a lot. So let's kind of think about this. I would not expect you to do what I'm about to do on the test. However, it's a nice visual for you to see what's going on. So I am above 0 at 4, at -4, to infinity, right? So I'm just looking at the x's right now. I'm also, from -1 to +1, I am above the x-axis. And I'm doing open circles right now because I'm not equal to 0. All right? And then lastly, at 4 to infinity, I'm above 0. So I basically took this graph and we put it in like a big trash compactor and slammed it down flat. Okay? That's what we're looking at when we're looking down here. So today I would encourage you to write this down, but it's not something you need to have later on. So let's talk about it. What's my starting point right here? What's this start at? Come on, where's that? This goes on to where? Where's it go? Infinity, it goes to negative infinity. I'm going to put that over here. So it starts at negative infinity. So my interval notation is going to be my starting point. So I'm going to put negative infinity. Where's it stop? Perfect. So it stops at -4. What symbol do I use to show that there's a break? That little u. Yeah. So I'm going to have this little u, and then I deal with this. So this is from -1 to +1. And then I have a break. So to signify that, I put a u. Not an actual U. I don't want you to put like the little tail on it. Just a little curve. Looks like a parabola almost. And then our last thing is just going to be 4 all the way to infinity. Questions? So we did the interval. Now we got to do the inequality. So the inequality, I'm looking at this. I'm looking at numbers that are greater than or less than 4 for this one. Are the numbers greater than or less than -4? Less than. Yeah, so I'm going to start with that. I'm going to say x is less than -4. And then I'm going to put or. Every place that I have this symbol, I'm going to put or down. So I have that. And then I'm going to basically have that sandwich one that we had in our warm-up. So I'm going to have -1. I'm going to have my inequality is less than x, which is less than 1. And I'm going to put or. I'm going to try to squeeze that in there. And the last thing is going to be what? X is what? I'm going to compare it to 4. I don't compare it to infinity. I never have infinity in my inequalities. So it's x compared to 4. X is greater than. Yeah, it's going to be x is greater than 4. And so that is going to be my answer. Questions? All right, next problem then. I'm going to speed us up a little bit, not too much. We're going to factor this. What's it factor to?
X minus 3, x plus 5.
Minus 3 and plus 5. So that means I have x-intercepts of 3, 0, and negative 5, 0. Now, chapter 6, quadratics, I'm only actually going to really need 3 points to get a picture that I can shade and do all the other stuff that I need, or to look at comparing it to 0. So we're actually only going to find our vertex. So what's halfway between negative 5 and 3? Negative 1. So our axis of symmetry is right here. So let's plug negative 1 up here and see what we get. Or you can plug it in up here. You'll get the same thing. I'm going to actually choose up here. I think it will be a little quicker. Maybe not, though. So my vertex is negative 1, negative 16. So we're not going to scale this one because our scale is actually on the graph. So we're going to actually do some bad math here. We're going to just go ahead and put our dot way down there. And so this one actually we see every year, and every year someone's like, why would you leave that there, Nichols? And every year I give the same answer. Every parabola you do is not going to fit on the graph. So I'd rather show you one in class than throw one at you on the test. So this is what we got. So our parabola looks like this. Now, when we look at our functions, we have our quadratic right here, and we're comparing it to 0. We're saying our function is what compared to 0? Less than. Good. So I'm looking at below 0. So I'm looking at this region right here. So really I just look at my x-intercepts. That's kind of like my 2 points of interest there. And so I'm going to draw this out. So I'm at negative 5, an open circle again, and that goes all the way to positive 3. And so it connects like this. I want you to try the interval, and I want you to try the inequality for that notation. And I'll even put up for the inequality, it's going to be something like this, and it's going to be something like this. There's only one item there, so we only have one thing to do. So put those numbers in. So that's it. So our function is below the x-axis from -5 all the way till 3. So all the numbers between those, that's what we're looking at. Questions? Who remembers how to factor something that has 4 terms? You cut it in half, that's right. So I'm going to cut this in half. So what is my greatest common factor from the first two things? X squared. So we're factoring by grouping right now. So I got x squared. So inside the parentheses for these two items is going to just be an x plus 2. Now remember, you have to get this parenthesis to match up with whatever's on the other side there. So I need to have x plus 2 in there. So I'm going to go over here, and I'm going to put a parenthesis. Well, what can I take out of -4x minus 8? I can take out -2. I can take out 4. I can take out -4. So you actually, once you get to 4, it's the choice. Do I take out -4 or do I take out +4? What should we choose so we get x plus 2? I've got both answers actually from you now. We are going to take out -4. So if I take -4 out, I times it by x, I get -4x. Take -4 out, I times it by +2, I get -8. And so this is greater than or equal to 0. This is the first time we've had an equal to when we've been doing problems like this. So now I'm looking at this and I put this together and I get x squared minus 4. So the two things on the outside go to one on the inside. And then our factor that's the same goes together. And so that is going to be x plus 2. Can I factor this again? Yeah, so this is the difference of perfect squares, and we get x plus 2, x minus 2. So my zeros are going to be -2 comma 0. It's going to be 2 comma 0. And I get -2 comma 0 again. So what's happening at -2 comma 0? Do I put like 2 dots or what do I do? It's a bounce. Good. So it's a bounce, and then 2, 0 is a cut. So degree 3 is what we're looking at. Is that together or is that separate? Separate. So where am I going to start? Am I going to start up high or am I going to start down low? What's our picture going to look like? It's going to be like this. That's good. So I go like this, bounce, cut. So we're looking at when is this function above or equal to the x-axis? This one's kind of tricky. So right here actually at -2, we have a dot. It's just there. It's equal to 0, but then it goes back down. And then at 2, we are equal to 0, which is fine. And then it looks like it goes on forever. So this is how you deal with it. There's a couple ways. I will be content if you just put x equals, and notice I'm actually starting with the inequality on this one. Put a 2 here, or a -2, and then we're going to go, or x is greater than or equal to +2. For the bottom, I'm actually also okay if you just go like this for our purposes, and then you would do a u, and then you would put from 2 to infinity with a parenthesis. You actually also could, don't really recommend, don't think you really need to, but you could go like that or like this to show that, but you don't have to. I'm fine if you just write x equals, -2. That would be fine. Questions? You know how we save the hardest problem for the last problem? We didn't do that this time. Because you're going to do this problem. You're going to try it out. So this last problem is simply a line. So it has a slope of 1/1, and I want you to graph it and try it out. And you can work with somebody next to you. I'm going to give you a head start of about 2 minutes to try to get everything done. All right, so you can look up there, see how you did. What questions do we got?
So in the handle notation, how's the 2 looking back?
It's not. Good catch. I was waiting. Anything else? There's nothing else. That was it. That's good. All right, there's one last thing I'm going to show you. And then we're going to have to do your lovely course recommendations. So I just want to show you something really quick. So what is my x-intercept from these 2 points? What are my x-intercepts? +2 and -6. And it's a cubic, so it is going to start down here, go up, and then bounce off this and go up. Now, Chase actually asked this question in the beginning, and I said I would kind of address it more often. When you're dealing with a y and the inequality, that's when you have to dash. And so I will not only dash this as I go through, but I also have to do shading. So I have to shade for this solution. And so in this case, I'm going to shade down here. This next one, you notice it's like the exact same function, except it's compared to 0. And so when it's compared to a number, we've been comparing to 0 for the past couple days, but on Monday, you are going to compare it to different numbers. So I'm just going to say a number. So I'll put the -6 right there and the 2 right there. But this time, the question or the premise of the question has changed because now it's asking me to make a comparison. So if you have a y here, you have to deal with shading, or you have to deal with shading and you have to deal with a dashed or a solid line. If you have a function and then you're comparing it to a number, you always have a solid line or curve or whatever it is, and there is no shading. So do not shade on the test if you're comparing to a number. You can do something like this and say, hey, I'm looking at this portion of the graph. That's fine. But you're not shading like we did on the first day. So there's a difference. So that was a good observation. Any other questions from the lesson? Okay, seniors,